we kind of started with the Bible says therefore, and Sandy said something a moment ago which was sort of, what should Christians think about this? I hate that as an approach in a sense, because what should Christians think is go read it yourself, seek truth, and I think Jesus said, seek and you shall find, knock on the door shall be open. And so the basis is go look, go seek, go find. And I don't like the idea that there is a certain view that all Christians should have because it's the orthodoxy. That's what Jesus knocked at with the Pharisees. That's what the Reformation had to do with the Roman Catholic Church. So now I come from things. David mentioned the scripture which says they are without excuse because they can see the creation, so they can see the characteristics of God, His eternal nature. By looking at creation, you can see that, and everyone can see that. Everyone kind of knows that, really. If you think about it, you kind of go, consciousness, a life from nothing, the universe from nothing. We kind of get that. And there's a theological understanding, which is there are the two books of God. I love it in the sort of in the Scots. There's the wee book of God, the Bible, and there's the muckle book of God, His creation. So that's the way I tend to put it. So what I want to do is to look at from looking at creation, and I want to do a 10 minutes overview of geology. What do we actually see? And I want you to sort of shout out and be a bit more interactive. So we've hang on, starting wrong place. We've got the that sort of map of the world there. And I'm just going to kind of point out a few things that I see, just to give you an idea of what I'm looking for. So if I'm looking at that, I can see that there's some big mountain ranges across here, and there's kind of a big swathe of mountains here. You'll see them across Europe, and particularly the Himalayas there. You'll see this break through the middle of the Atlantic Ocean. There's the same thing going on round here. I'll refer to them as mid-oceanic ridges, like the mid-Atlantic ridge, but they're in different oceans. There's something different going on here. There's not the same thing in the Pacific. The Pacific and the Atlantic are different. But there's similar things going on over there. There's some trenches going on here. If you look at the Americas, what do you notice about the Americas? Sorry?
Mountains down the east.
Apart from this, the west, but yeah. Big mountain ranges down the west. Okay, so just kind of, I want you to kind of go, what do I see? What's the overview of the geology? This one is the earthquakes and volcanoes around the world. What do you see?
It's very heavily concentrated where the mountain ranges are.
Yes.
But aren't a lot of the mountain ranges and stuff to do with where the tectonic plates are /
yes. were? Well, that in a sense is the conclusion from the evidence. So the evidence is that, and the conclusion is tectonic plates. Okay. So yeah. Anything else you see? I talked about the mid-oceanic ridges.
Pacific Ring of Fire.
Pacific Rim of Fire. So this is Pacific. Yes. You've got this Ring of Fire. That's what it's referred to.
In the middle.
What's happening in the mid-oceanic ridges?
There's a crack all the way along.
So there's volcanoes and earthquakes around there, and you can see them better. You can see this one, the one which pushed. The Himalayas up, India up. You've got these ones down the side, down near your mountain ranges. Okay. So as you say, the conclusion in a sense, it comes from that you've got tectonic plates. This is crustal thicknesses. And I want to dig into this, but what do you notice around that? You notice that it's got the 20, 30, 40, but it's got 45 as well. They throw that in, otherwise there's not very much going on. What do you notice?
The further inland it is, the thicker the crust.
Yeah, so
The
on
sea's
the
very
continents it's thicker crust. Roughly speaking, how thick is the crust on the
40.
continents? About 40, yeah.
That's 40 kilometres
Well, 40 kilometres thick.
thick.
That's very thick.
Not very thick.
It sounds quite thick, but
10,000
compared to 10,
miles across,
Do
that's
you notice-
13,000 kilometres.
Do
There's
you
only
notice
45 of crust on the
Almost all of it
16,000.
yeah, you're right.
is about 40 kilometres thick
Yeah.
on the continents. How thick is it on the oceans?
10.
Mm,
10.
Or
Less than 10, but yes. And then it suddenly goes from one to the other.
Yeah.
And if you didn't have the 45s and these odd 40s, you know, there'd probably be nothing. Here. Couple of spots where there's something up to 60, something up to 70. What can you tell me about 70 and 40?
Where the tectonic plates are met, where one is
Is
slid
it-
and the
yes.
other pushing it up? Or?
Yeah, 70 and 40, actually, the average is around about 35. 70 is double. So what do you think is going on here?
Squeeze.
A lot more than in other places.
What happens if you add 35 to 35?
There you go, 70.
70.
So, roughly speaking, what's happening there, and you can actually look at the cross-section, and exactly what's happening there is you've got one continental crust going over the top of another continental crust.
So it's
you
double
can
the thickness.
really see,
Overlapping.
and there's another one here. This is, the moho is Mahotovich, a Russian guy, discontinuity. It's where the granite and the basalt changes. So you'll notice there's lots of blue areas, less than 10 kilometres. The majority of
It's
the
not just the
continent
sea that's blue, it's just the crust that's...
is just, yes.
Yeah, it's very good.
Yeah?
It's not.
So that you can tell by the way earthquakes and things and the seismic waves bounce around to. That's a digital thing.
No, yeah.
What else do you see around about that? What stands out?
The mountains.
No.
Because
They're
they're
red.
red.
Yeah, so you've got a couple of mountain bits again, up at 70. You've got virtually nothing which is green, and you've got very little which is red. Okay,
Yeah,
you've
most
basically
of
got
them.
two thicknesses going on. The oceans, by the way, are on average 6 kilometres. So you've basically got 6 kilometre thickness for the oceans, and you've got 35 kilometres thick for the continents. Two things going on. It's not a smooth transition. That's what I'm. Okay, this is the sedimentary thickness. So we've basically got molten granite type rock everywhere. On the continents, it's around about 35 kilometres thick of granite. The oceans are slightly different. It's about 6 kilometres thick of basalt. Similar, but slightly different densities, slightly different composition. Forget all that. This is just the sedimentary. This is the sandstone, the limestone, all that else, which sits on top.
Deposited by water.
So what are you seeing on that? Where are the thick bits?
Canada.
On the coast.
Yeah,
Gulf of
these are
America.
kilometres.
Yeah! Hurrah! Gulf of America.
Yeah, here,
Gulf of Mexico.
And
Gulf of Mexico a lot.
in the north.
But why do you think there's
Northeast
lots of
Africa?
sedimentary going on there?
Can you tell me?
Is there
Currents?
rivers coming out? Or?
Rivers coming out, so rivers are going to flow that out. Where are the mountain ranges?
On the,
We've already
on the
mentioned.
west.
Sorry?
On the west.
On the left hand side, on,
Yeah.
on the west. So where's all the sedimentary stuff going to flow?
Flowing out.
Down
It's
here.
gonna
Dump
go-
into the basin.
Yeah. And this is where the Mississippi comes out. Yes,
Yeah.
you've got a lot going on there. Where else are you seeing lots of sedimentary?
Northeast Africa.
Yes.
Around there.
Mediterranean.
Nile.
So that's the end of the Mediterranean. Filling up the Mediterranean. Yeah.
The
What rivers have you going in today?
Nile.
Nile coming in, Egypt there, filling up that. Yeah. Okay, it kind of makes sense. But where you've got that sort of basic flow down, you know, whether that's slow or fast, that's where it's coming. All the way around the coastlines.
What's this measurement, James?
This is kilometres thick.
Kilometres, isn't
So
it?
you've got up to 15
Huge
kilometres
amount.
thick in some of these places.
What
But
is that
mostly you're talking about 10 sort of kilometres thick.
Is it up in the north, all along the top? Is that also just rivers? Or
Yeah, you've got stuff going north as well.
Was that locked under ice?
There's not so much rivers going that way, but
Yeah.
which is an interesting one as far as where I'm going, because where I'm going is a flood model and a flood understanding, because I think what all this does is scream a flood, but I kind of want to start from the evidence, not start from the conclusion. This is I forgot what this is. This is okay.
Pacific.
As well as the granite basalt layer and the sedimentary stuff on top, you've got a layer underneath that which is solid. That's called the lithosphere. Lith meaning rock. So this is the total thickness of the lithosphere, and it goes up to 100 kilometres thick. But you'll see that there are thinner bits. Sorry, you can't see the numbers. It goes from about 6 kilometres to about 250 kilometres ish. So it's a little bit more difficult to quite understand. But underneath that, 6 kilometres of basalt underneath the oceans, you've got some solid rock, but not that much. And underneath the granite, 35 kilometres thick granite, there you've got some more solid rock. But you've got thinner bits. And again, where are the thinner bits?
the ocean.
Around the faults, mid-oceanic faults. Interesting thing going around the Pacific. You notice how the Pacific is different from the Atlantic. I'll keep coming back to that, and we've got you kind of maybe want to get your head around what is going on between those two areas, and why are they different. Okay, so that's what we've got. Now, going from a biblical understanding or going from a geological understanding, we had a Pangaea in geology. We had one place, one land altogether. From a biblical idea, God divided the land from the water. There's a verse later which talks about the water divided, when the land was divided. Now I'm going to these mid-oceanic ridges is where that bit divided from that bit, and you'll have seen that those kind of fit together, jigsaw. And if you go by the continental crust rather than the coastline, they fit better together. So what is this which is going round here? And what
Looks like a scar.
it looks like a scarf. And I want you to notice a couple of features of it. There's these tangential cracks, which are absolutely massive. And particularly, because we're in Scotland, you can track that one, and I'll hopefully show you if I've got the right images in. You can track that right the way through Ireland and the Great Fault in Scotland, and see where this tangential crack happened. Now, standard geology will tell you that we've got a continental drift moving a few centimetres per year apart. Now, how on earth did those tangential cracks, you're splitting like that, well, you'll just keep splitting like that, and you keep going apart, a few millimetres per year over millions of years, it'll keep doing that. You've got cracks going sideways. Now, what happens if instead of it going really slowly apart, it's going catastrophically apart? Every volcano we've ever come across catastrophically explodes and then will trickle on for a while, etc. It goes ballistic and then it kind of goes slowly, etc. And if those are going catastrophic and a bit of it is going and getting shoved up, if I took this bit of carpet and I lift a bit of it up really quickly, I would rip sideways because I'm just lifting that bit, not lifting those bits, etc. And you end up with these cracks going, rocketing out. Now that's the only way I can see those tangential cracks happening. And that's what you see everywhere. And if you can find another mechanism which does that over millions of years, and these cracks,
You'd be very...
then
very rich.
I'd love to hear it, because I cannot think of a mechanism which would do that. So let's go back to this. So you've got solid rock-ish, 100 to 200 kilometres thick, but it's all sitting on a molten core. And the diameter of the Earth, or the radius of the Earth, sorry, is 6,300-ish, 6,500 kilometres thick. And you've got about 100, 200 kilometres of solid rock on top of it. Molten core, solid rock, floating on top of it. It's only 2.5% of the thickness.
Is that like is it comparable to like an egg, chicken egg?
Yes. So you've
Yeah.
basically got, we're on a molten ball with this 2.5% of the radius is this really thin crust. It's floating there. Okay? And I want you to get that idea that we're not standing on rock, we're standing on rock which is floating on molten rock. Okay? So the cross section looks like this. Round about 8 kilometres thick of basalt, oceanic crust, about 35 kilometres thick of continental crust, which is granite, thank you. My brain went on that. Underneath this you've got this layer which is sort of solidified. So you've got about 100 kilometres thick, and it's all floating on here. So because if everything was just molten, we would all be covered by water. Because it's just sitting there, and the water floats on top of everything else, on top of land. So we would all be underwater. So why are we not underwater is the more interesting question. Some people are saying, where did all the water come from for the flood? The question really is, where does land come from? Okay, so if I look at this, sorry, I'm going to escape out of this and make it bigger if I can, very quickly. Sorry, apologies. Should have done this. So roughly speaking, we've got the oceans. I'm just going down a couple of 100 kilometres, roughly speaking, till the molten bed. But we've got 6 kilometres or thereabout of basalt, 4 kilometres of water. That covers 70% of the globe. Okay? So if I evened everything out, instead of covering 70% of the globe, it would cover 100% of the globe. The thickness of water would be 2.7 kilometres thick. We would all be under, on average. The continents are roughly speaking 35 kilometres of granite sitting on this molten bit, and and that's sticking up on average a couple of kilometres. Because it's slightly more buoyant, it's not as dense as the basalt. Granite's lighter than that. The Himalayas, you've got 70 kilometres or 75 kilometres worth of rock, mostly granite, and that's sticking up about 8 kilometres. As I say, if you took the globe and made it as small as a billiard ball, it would be smoother than a billiard ball. It's incredibly smooth. So your highest peak is 7.8 kilometres. Your deepest trench is 12 kilometres, and your total diameter is about 13,000 kilometres.
Yeah,
13,000 kilometres. Okay, you're getting the idea. We're a really thin crust.
That's a great picture, as smooth as a billiard ball, the Earth is really. But we're seeing it in
It looks lumpy
its
to us.
size, it looks lovely to us, but it's smooth as a billiard ball.
So,
It's
We will micro
same idea, like even if you looked at like an egg under a microscope, it
Yeah.
feels smooth to
Right.
us, but it wouldn't look
yes,
it.
yes.
That's cool.
So, the question is why we've got any land. Oceanic crust, about 3 grams per cubic centimetre, or 3 tons per cubic metre. And a cubic metre of water is 1 ton. So it's 3 times as dense as that. That's your basalt oceanic crust. Continental crust is a bit lighter, about 2.7, 2.8 tons per cubic metre. So that's why it's lighter, and it's also 35 kilometres deep. So like an iceberg, there's some of it sticking up because it's less dense. So that's why we have some continents sticking above the water. And that's where your most of your sediment is, just off the off the continents,
So,
filling in that gap there. Yeah.
So you're saying it's not because of there's not just land because of the plate, like I'm just remembering geology was saying that like the plates are sliding over each other, forcing one out of the water and stuff like that. You're
Yeah.
saying it's because of the actual density that the one
It's
actually
floating.
rises
If you
out.
it's
had
like an iceberg.
If
yeah.
you had 2
Makes
plates
sense.
squeezing past each other, and they were both as dense as each other,
No,
one would go down and the other one
Go
would
down.
go up. It would go thicker, but it wouldn't kind of poke out above the water because it's all about buoyancy. I kind of wanted to do a sort of demo where you've got the bits of wood on water and a layer of oil which substitutes for the water, because you need something which is lighter than the molten rock underneath. So yeah, you've got the picture which is often given. So it's called isostasy because iso and stasis, the same balance, and that's why the oceans go lower, because they're denser, and the continents are lighter. The mantle rock is about 3.3, so it's all pretty close. So my question though, going back to where are we? Somewhere around there. That one. My question is, although it doesn't come up awfully strongly, you'll see on the continents there are sedimentary rocks. About 70% of the continent surfaces are covered by sedimentary rocks. So I want you to think through, how did that happen? And as David said, they are basically laid down underwater. Sandstone is laid down underwater. Limestone comes from sea creatures. It has to be laid down underwater.
The White Cliffs of Dover.
The White Cliffs of Dover, yeah, has to be laid down underwater. Everything needs to, virtually everything needs to be laid down underwater. Some people will argue about things like the Cognito sandstone. Was it laid? Are they sand dunes which were then squashed later? But the angle of them proves that they're actually laid down underwater. But most geologists would absolutely agree that 90% of those sedimentary rocks are laid down underwater. Now the question is, if they were laid down underwater, how did you ever get the continental crust to push down enough for water to get over it? Now,
Because it's really buoyant.
well, yeah, because it's really
It's like
buoyant.
pushing a balloon into the water.
It's like, how did you
You can't just do
get
it.
driftwood to land on top of an iceberg? The only way you can do it is if all the icebergs covered. The only way you can do that is if all the continents were covered. Now, I've posed a question. It's a question which is a question for a flood model, and it's also a question for a normal geological model. Normal geological model will say, well, each of the continents were inundated with water about, in the case of America, about 15 times to create all the different layers. But how did that ever happen?
How many million, billion years ago was it?
Don't the ice ages kind of explain that though?
Ice Age is fairly small scale, really, because you're putting a load of ice and a load of weight, and you can have kilometres thick of ice on top. That's not a lot of weight in comparison to what we're talking about
Okay.
today. But yeah, no, it does. I mean, it does affect it, and maybe you can. But if you've got ice on top of it, how do you get sedimentary rock?
Because that's scouring it.
on
Well, the
top?
ice would push it. potentially.
Yes, and it can scour it, and it can take it from there to there. But we've got this huge quantity. I mean, some of these rock layers are hundreds of kilometres thick.
So it can't be like dams from rain or something like that.
What
At that
has
scale.
happened historically is geologists have looked at this and say, oh, it's an outflow of a river. Which river? Oh, well, it's an outflow of a river.
Which must have been there.
And it doesn't. That must have been there.
It must have been there.
The thing is, if there was a river there, you would find traces of a river there because it would
Yeah.
be eroding where the river was.
Maybe other erosion.
Okay, let's look on to now that's the reality. It's a little bit like every simple thing. It's more complicated than that. So that's a cross section of some continent. I can't remember which one. So it's a little bit more complicated. But remember that's a lot of a vertical exaggeration there. So it's a bit smoother than that. But it's still it's like that. UK. This
So-
is the oldest. This is the granite, volcanic, igneous rocks. Metamorphic just means that it's been heat affected. Not surprising, things next to molten rocks get heat affected. Up to what's on top, and through Britain you've got these getting newer and newer and newer. Just watch my time. But notice these cracks, where the edge of that blue line, that one there. This one's less noticeable between the rock layers, but it's easier to see. That's a great claim, etc. So you've got the lowlands, Edinburgh to Glasgow, coming in there, and that goes. You can trace that all the way to Mid-Atlantic Ridge. How did that happen? So I've not quite answered that question. This is up in Canada. It's just sort of randomly taken somewhere that they've done a good geological layer. So look at the sedimentary rocks. Just again, take an overview. What are you kind of seeing in that overview? These are the rock layers, different sorts. Sorry, it's Alberta. That's the topological, and that's the rock layers. Roughly speaking, what are you sort of seeing? How would you describe that?
Is that like a Is that the light yellow? Is that the sedimentary rock?
Well, these different colours
It
are all
looks like a
sedimentary
floodplain.
rocks.
They're all sedimentary rock.
There's a lot of variation in the edge.
Yeah.
Yes.
This is the mountain.
Well, that cuts through. So this yellow one is on top, flat across there. On that side, it's going off gently. This side's cut through, much more drastically, and that's where the mountains are. This is that looks like a coastline. It isn't. This is up to the mountains, and then more the mountains, and then down to the sea.
Oh,
Yeah.
yeah.
But it's sort of scooped up. That's the left-hand side of the Americas, basically. And so what's happened, a bit like, sorry, let me go back to this. What you've got here is Scotland is the base rock which has been pushed up, and then the other layers are pancakes on top of it down to the White Cliffs of Dover. White Cliffs of Dover were worn out by here. Yeah, this is crustaceous, worn out by here. There's none of that, so we don't have hard water. They have hard water. We've got pretty much granite up here. So that's your old one. So it's all down there, and then it's worn off. It's like you've chopped off the top lot, but because the granite was sticking out most up here, you've cut all the other layers off, and you've only left the top layers down here. But because that's nice and hard, it doesn't wear off quite so easily. So it sticks out of the ground more. So the oddity is that the highlands have the bottom layers. You can go from North Scotland down to England and go through, up through the layers.
Yeah, so is that rock that's in the north of Scotland, is it underneath England, but it's just deep down?
Yes,
Yeah.
yes. So if you followed that, and if you went
So
to
the oldest-
Whitby,
yeah,
you'll see everything
Exactly.
slants towards
yeah.
the south.
Yeah.
It's all
Right,
doing,
so
and that's possibly
the
to do with it had more ice on it, and then it sprung back up, and it's difficult to quite know. But isostasy means that things have got to do their buoyancy thing. If you take a load of ice away, then it will bounce back up again, and apparently Scotland's still bouncing back up again. And this is very similar, except east to west on the west coast of the Americas, up in Canada. That's what was left behind after the 2011 tsunami in Japan.
What's that,
About
sorry?
after the 2011 tsunami in Japan,
Is that
about
measuring tape?
2 foot, about 60 centimeters, was washed in, and about a foot, 300 millimeters, was washed back out to the sea. So that's roughly speaking what a tsunami normally does, and that's about that. We have rock layers, which are
meters thick.
kilometers thick. What scale are we talking about? And that's what I kind of want you to have in your mind. That's the sort of scale, and that's and what the characteristic of that is they're horizontal layers. There's nothing in between them. If you had that horizontal layer laid down and then it rained, you'd have valleys, and you'd have valleys cut, and then the next layer would fill in those valleys, and you'd have this line which goes up and down with valleys and things like that. You don't. You don't have any soil there, you don't have any animal burrows, you just have one layer on top of another layer, on top of another layer, thick.
Perfect sandstone.
And they cover, this is one of those layers across North America. They cover
Most of
60% of the country. That's another layer.
Cape rocks.
That's another layer.
types of sandstone. They're just named after you.
These are the different layers that you see. So what you're seeing is these massive layers covering the whole of the continent, massively thick. Now, going back to the question, sorry, that's not right. The question of how on earth did you get the water to cover the land? I think in the flood, And I'm just going to kind of give you quickly the sort of what I think is the answer. When it talks, the Bible talks about the fountains of the deep. If you take that to mean that, and this, and that they're the volcanoes of the deep. And if they split open, like a volcano split open, but on a long line, they're going to throw pulverized rock matter into the air, and a normal volcano, it will rain down water. You're underneath the ocean, so you're going to push a lot of water up as well. It's going to rain down water for, if it's a really bad one, for a couple of days. It didn't, it did it for 40 days. So yes, I think giving you a sense of the scale. You get these massive cracks going on. You've got the ark in a safe place, probably starting here, certainly ending here in Sumer, Mount Ararat, somewhere around there. That's well away from those explosive things. You've got 40 days of that. If that all started with runaway, and this is speculation, but runaway radiation, a magnetic pole shift, the cosmic radiation leaks through. Radiation is not standard. It is, you're told that it is in science. I've taught it as such in science. But a nuclear bomb, a nuclear power plant will show that you can adjust the radiation rate. In a nuclear bomb, it goes catastrophic. In a nuclear power station, you just get it to go continuous. Nearly critical, nearly going catastrophic. And things like cosmic rays affect radiation. If you had a magnetic flip, and there's good reason to understand that you have, then all of this would have heated up. If that heats up, instead of the density of this being nearly 3, what happens when the density, when something heats up? It decreases.
Nice.
So this is going to raise up, and there's good reason to think that the Pacific actually had a new layer, because there is a subduction plate underneath the Americas, which they can detect. That was then hot, less dense. That raises everything up. That pushes the water onto the continental crust. That explains why there's water everywhere. You've got loads of water going on. You've got tsunamis everywhere. It is absolutely massive. And you lay down all your sedimentary rock. Now, as part of that is my take from all sorts of scientists, potential image of what could have caused that. And I come to that kind of from, what's the evidence? What are we seeing? How can we explain it? Because I've never come across anything which
Is that
slow,
from,
gradual.
That's from space as well?
Sorry?
That's from space, pretty much.
No, that's just a map
But like,
from
okay.
topological.
I suppose because you can't see
bathymetric.
that. You can't see through.
Yeah.
But the bathymetric shows those lines.
Bathymetric means the depth of
Yeah.
ocean, like
Sorry.
a bath.
Bathymetry, yeah.
Bathymetry. Okay, so that sort of, I kind of want to walk you away with the sort of, you can start with the physical world that God gave us, and an investigation of it, and lead to how could this have worked out, and also sort of put it together with, well, we've got some clues from the Bible, and we know the Bible's reliable for other reasons. David announced some of them from the prophecies, from the archaeology, from whatever. We've got a lot of different reasons to trust the Bible, and that's not blind faith. It's just look at the evidence. and we've got a potential model. Now, I wouldn't take the model that I've outlined anything like gospel.
Mhm.
That could be shown to be wrong by something I don't know about, or something which is then discovered, or whatever. But I kind of want to give you an idea of what I think is the scale of everything, and roughly how it fits. Does that make sense?
Yes.
Yeah.
Questions?
And it's not so much a question, more adding on to some of your points, because I actually think a lot of it makes a lot of sense. Because, so we know there's such a thing as super volcanoes. Now, luckily enough, none have ever went off in a lifetime, and hopefully they won't. And while they can't say 100% what would happen if one went off, we know it would be devastating. And as far as I'm aware, none of the volcanoes that would have been down that ridge would have been a supervolcano per se, but that amount of volcanoes could possibly have a similar impact to a supervolcano.
I think they'd be bigger than what we call them.
Possibly, and we know if any of the supervolcanoes went off just now, it would essentially wipe out life on Earth, because it could potentially blow out the sky. But, and okay, my science of this is not 100%, so I could be way off. But when you take into account of that going on underwater, and a lot of science have already shown that under a lot of the rock there are almost hidden oceans. So if a lot of them were set off by that happening, that would also explain where a lot of the water came from, and it raining for so much longer.
Yes. In a sense, you've got to answer where the water came from, but you've also got to answer where it went from. And the idea, I mean, there's something woodite, which there's 5 times as much water under in the rock layers underneath the Earth as there is on top. It's very little on top, really. It just covers 70% of the globe.
Yeah, but that's the other
Unfortunately,
thing,
not
is
more.
obviously due to the tectonic movement, some of the water will have went back there as well.
Possibly, yeah.
I mean, I think, you know, my model is keeping it really simple. The way I visit it in my thing is that the key thing is the Earth is so fragile, okay? And we've got these different densities, and the land is sitting up floating on something that is you know, can
Unstable,
sink.
yeah.
If the structure of the Earth is at all damaged, then the whole lot could sink. It's a floating thing. It can drop. So again, you get these volcanoes. It says that the fountains of the deep broke, whether that's volcanoes or whether that's water that's underneath the Earth is coming up in the account. But anyway, it's fragile, and if you know, once the ocean crust, if it cracks somewhere in a big way, then there are models that show it just floats into the magma, and they're finding there's a lot of research at the minute going on. There's great big chunks of what was crust lying in the mantle, in the Earth,
Deep inside there, yeah.
which they don't really have any explanation for in their slow model. There is it's a catastrophic thing. The evidence is just so great that there's a catastrophic thing went on. The Earth is fragile. Whatever, it's not stupid what God says that the Earth could be covered, because as soon as the strength of the structure breaks, then it all falls to the centre. That's the way it works. The lighter stuff's pushed to the outside, the water's pushed to the outside, all the heavy stuff sinks. The land, even the light land, is 2.8 tons per cubic metre. The water's only 1, so it gets just squelched to the top, and all this stuff gets pulled. The solid stuff gets pulled to the middle, and you're there with the Earth as it was in day 1. The water is covering the whole Earth, and that under the flood is what happened. Is what I believe. It became like that again, and obviously it was a terrible time. He was in his boat. It was interesting that James pointed out that it's quite a stable place where he was. If the ark was kept in that zone while the rest of the Earth was blowing up volcanoes and everything else was getting fried, but you know, again, if that happened and all the water came to the surface, the Earth is still rotating at 1,000 miles an hour. The sort of forces just ripping
The moon,
hills to bits,
the
and
moon's creating
all the
tides.
plant matter that was on the Earth is all in the water. Everything is in the water. There's loads of dead creatures, and then when God calls it to a halt, which I believe God started it, and God called it to a halt, and then we get these the biomass that's like the timber is get deposited as coal. It's where we get our coal beds from. The sea creatures, it's the
algae,
the limestone,
oil.
the sedimentation. The water's filthy, and then all of a sudden it's going calmer. God's calmed it down, and it starts sedimenting out. And we've got this 70% of the land mass of the earth is covered in great big thick layers of sedimentary rock. And again, water is such a sorter. That's why we get pure limestone here. Pure coal, a layer, then a hard layer, and there's models that explain why it's pure coal, then why it's pure stone, and then, like, you know, in Durham we've got seam after seam of coal, and it's pure coal, and then it's pure rock, pure coal, pure rock. There's no model, there's no explanation. The flood is just the best explanation of how the geology on this earth, as far as I'm concerned, comes about.
Resources which I think are out there. There's Answers in Genesis. Answers in Genesis starts with "the Bible must be true, therefore," which I have a bit of an issue with, and certainly as far as talking to a non-Christian, I think it's the wrong place to start. You've got to kind of argue why you think the Bible's accurate. To take it from there. There's creation ministries, which I would very much recommend. They take a more neutral stand on that, and they're going to go, this is the evidence, therefore. And creation.com, it's really easy to, and if you've got a particular question, go to there, type in the question, and there'll be a paper on there. There's tens of thousands of papers on different things. They're a good resource. There's YouTube videos. What is it? Is Genesis history? Genesis is history.
Is Genesis history?
Is Genesis
that's where
history.
the screenshot comes
Yes.
from.
Yeah. One of the
They go in
screenshots is
detail about the Grand Canyon.
And folks
The
like
layers.
Kurt Wise, and that's where I've got most of this stuff from, and they're geologists who've looked at this, and one of them's got a full model of how the Pacific Ocean crust catastrophically sunk down underneath South America, and it's been detected, it's there, and he's got this full model of how that would have affected it, and that's how that would have precipitated the Atlantic Ocean ripping apart, etc. Is Genesis history? You can type into YouTube. That's a good resource. What else?
Well, yeah, creation.com have the magazine as well.
Yeah.
There's loads of those next door.
Yeah.
Feel free to take those and keep them.
They're good to.
Sorry, I went way over. Apologies.
But little simple things like, on my farm, we get a flood every so often, a decent flood, and it puts down like 2 millimeters of sand and it's just sand all around the river banks and things. Okay. Now, 2 weeks later, the grass has grown through it. It's no longer evident, although it's also great evidence of the sorter. There's driftwood and stuff, and there's coarser bits of sand and there's smooth sand. It's laid down and it becomes great soil. It's alluvial soil. We've got some good land where it floods, and all farmers out years have used that as fertility because it's got biology with it as well. And anyway, the grass grows through, and yet that is the model that they believe has put all this sandstone on the continents. It cannot be. There is no biological activity in any of this sand in the sandstone. Like the Grand Canyon, there's no evidence of soil, no evidence of worm tracks or anything like that within the sandstone. It's just pure sandstone.
If you took the billions of years timescale, it would work out of a sedimentation rate of 1 millimeter per 1,000 years.
Which is laughable.
This is laughable.
There's more dust on our
soil.
carpets in a year than
Right,
that.
more
It's just,
right.
yeah.
Mm-hmm.
So trying to get around what's possible.
It's such areas of the earth. So the flood,
I mean, there's a lot more to explore.
Oh, wait, so with your model that you're thinking, is it happening once all the continents have split it's not Pangea when the flood happens.
So,
And what would be your thoughts around Pangea splitting and
so
stuff?
I think the evidence shows that there was a Pangea, that Africa and South America were locked together jigsaw style.
Yeah, they all fit
style.
together a bit too nicely otherwise.
Yeah. Yeah, although there is a bit of a question there because they look like they fit better than they do if you actually take them. But if you think about it, you've got an awful lot of erosion stuff going on. So you've taken a bit off that. You've not got pristine jigsaw pieces. But I think that probably the sequence of events was either there's a possibility of a magnetic a twist, which is what caused it, and there's magnetic striping which goes on in the seabed, which is maybe maybe it's settling. There's a little bit of a kind of misinterpretation, I think, of that, but something's going on, and the magnetic poles have shifted at different times when rocks have solidified. So that's more evidence which you need to kind of account for. But if either that or the Pacific Ocean crust catastrophically, because if you take a bit of rock layer and it starts sinking down, it can go catastrophic because that bit's pulling that, and I'm trying to think how the densities go, but there's some oddities and inversions in the densities because it's molten and how it I can't remember quite how that goes, but it can go catastrophic, and so you'll I kind of alluded to that on the if you look at the Pacific. It's very different, and it looks like it's got a new layer, and it's solidified from the continents inwards, in big tranches, much wider, much bigger. It's got a different characteristic, and that one of those caused that the Atlantic Ocean to split, and then it would have gone like a zipper. And I think something like that would go catastrophic, and it because these all join up. I mean, this one and Iceland's Greenland. I mean, Iceland is a good example. A bit of an anomaly on there, but it's all volcanic. But this joins into this one and joins into this one, and that's the one which, if you split that open, you push this bit of India into that bit. Now, the models which they have India down here, and it moves all the way up there. Well, there isn't actually that's only that big, and it's pushed that above there that much, and there was no oceanic crust. There's no basalt in amongst that. It's just granite crust, 35 kilometres on top of granite crust, 35 kilometres. It's just like that was there, and then this split open, push that there, and then you crumple all this around there. So you kind of, it's sort of what makes sense with the data, and that's kind of where I go. I go, well, okay, what's your model? What's the geologist's model? Does that actually make sense? If there was an ocean between India and mainland Asia, then what happened to the basalt? It's not there. It doesn't make sense. You can look at the cross section through there.
Anyway, I certainly believe that it was one Pangea before the flood, and afterwards, after the flood, it was broken up. All the continental drift, I personally believe, happened under the flood. And it was just a time of tumult, and the landmass was pulled apart by all these forces of seabed falling in underneath each other. I think it is from my reading, it's the best explanation of how continental drift happened, how again, large tracts of water were trapped again underneath. Once the crust, it says after, God turned the fount off after 40 days. So 40 days of absolute mayhem, and then it settled down and things started to solidify again. The water's cooling, the crust is reforming under where it was molten, and the large amounts of water were trapped underneath. That's where we get our oil. Then it was dirty water full of dead creatures, dead plant matter, and that's where we get our oil from. So it all settles out. We just drill down into the top of it, pull out all these hydrocarbons. Lovely. How did they
Fossil
get there?
fuels. It's
There's
called
no
fossil
other
fuels.
way.
'cause it's
Fossil fuels. Fossil fuels.
We'll have a discussion about an aspect of that, but never
And
mind.
everything can be explained. These
Some of the fossil
observatories
fuels are below even the sedimentary rocks, which
Yeah.
creates an interesting thing of that, but
so
that's a
it's,
detail.
yeah.
But if it's all smashed up,
Yeah.
then you can probably.
It is, I believe that the model that they're using, geologists are using, is absolutely crazy.
That's
and
that's
I
our
do
present
believe that the
movement
flood-
on
The
the
flood
plate.
model gives an explanation for how the world is as it is, much better. And we're going to be touching it. We're going to talk about fossilization next week. And again, if we, I believe in a young Earth, and I think this things like this, this continental drift just happened 10,000 years ago. I'm going to say that. I believe it.
So the idea of continental drift in this model would be that it went
Catastrophic.
catastrophic, it went very fast, and all what we're having now is now that the Pacific is solidified, is we're getting the it's hardly moving anymore, but because it was moving and then it crashed into the plates, that's why the left-hand side of the Americas crumpled up. And Genesis talks about the mountains weren't that high before the flood, and at the end of the flood it says, and the mountains were pushed up. So that's part of the model. So the idea that, you get some silly things on discussion groups. Sorry, I was just remembering one of them, where sort of that amount of water to cover Everest. Everest wasn't there. Everest wasn't.
Was pushed up.
Well, I was pushed up afterwards. So
Okay.
the highest mountains were probably only
Having said that, Everest has got fossils on the top of it.
Yes.
Exactly.
All these mountains have, so they were pushed up after the flood.
So there's
So
water
there's
everywhere.
stuff going on.
Yeah.
And it's happening rapidly. Within this year, these things are happening. So Everest wasn't there, but at the end of the year, it was there because the Earth was still plastic. It's got massive areas of solidification, and we don't know the forces. But I strongly believe God started it, and He called it to a halt, and He made the Earth habitable again for us. He trapped hydrocarbons, so we've got energy, so the population of the Earth can get to 10 million before He calls us all
10
out.
billion.
10 billion. It's he created calcium carbonate so he could build concrete buildings, and he created so many things: coal, energy sources, fossils to make us think, valleys, and interesting
And
place.
some
to
of the
live.
things you bring up, they actually raise an interesting question, because you're saying about fossils and fossil fuels, but on the other hand, why would he give us something that is so damaging, or potentially damaging?
Well, he's in control.
No, but
we
it's
see this.
bloomed life from a few thousand, or from Noah to 8-7 billion now, and so we're here. God is delighting in His
That's a
creation.
big question.
Yeah, it's a big
It's a big
question.
question.
I was
It's
saying,
a big
Especially
question.
because we have discovered
but
ways to
God's ahead
well,
of time, and He
not
knows.
as effective. There are other ways to do the things we have used them for.
I kind of don't want to go there, particularly at this time. But I'm just going to bring in one bit of data, which is at the moment, because the carbon dioxide in the atmosphere is higher than it was 50 years ago, not than it was 1,000 years ago, 2,000 years ago, etc. And that's data which you can look up. In the last 50 years, I think that's the time scale, the planet is about 15% greener. At the moment, the deserts
Sahara's
are
getting
shrinking.
greener, yeah.
A plant has little holes on the back of the leaves, and it needs to stomata, and it needs to get carbon dioxide in. And because the levels, if it dropped any further, we were down at about 250 parts per billion, which is really not a lot. It's 250 parts per billion of CO2 to all the other gases in the air. If it had gone lower than that, plants really would have struggled. They pump CO2 into greenhouses. In a submarine, you would be about 4,000. We're only at 400. And human beings are fine. They pump up to about 4,000 parts per billion into greenhouses because plants grow quicker that way. So because the spirals on the back of leaves the plants will only survive if they let enough CO2 in. So only the plants with the big spirals survive, but then they lose too much water. That's why the deserts were growing. Now the deserts are shrinking. So what is the optimum is an interesting question. CO2 is plant food.
Oh, 100%.
So the idea that CO2 is bad is a slightly interesting one and needs pulling apart.
Something
I don't want to go further than that.
I can understand why, because that answered a question, but also gave me about 1,000 more questions.
Yeah, absolutely. Let's have that conversation.
In the flood model that I understand, the pre-flood biome, which is all of the ecosystem before the flood, was very different and was much more CO2, much bigger plants, much bigger insects. Like we find all these fossilized insects and things like a woodlouse that's 6 foot long. So like mega insect. I know, but there was one found on the east coast, just near Lindisfarne, 6 foot long, basically, woodlouse. Yeah, and so these dragonflies that were the size of like me, like 6 foot, and David Attenborough has done these documentaries about what life back then, or what it was like, and also inside amber, you can get amber, and there's air bubbles inside it. So they've actually started testing the air inside those bubbles and finding that there's really high levels, like 6.8% carbon dioxide inside the amber bubbles, which is fascinating because that's super high. But yeah, so and this is what and in the garden, like they were warm, they didn't need clothes, and well that's that, and so it could have been much more sort of tropical, much more warm. These big plants and big animals. You get dinosaurs that are huge, like the sauropods. They would actually breathe like a bird. They'd have different type of lungs they wouldn't be like a mammal lung. So there's all these different interesting things like how these super massive dinosaurs and insects could have survived. Yeah.
You needed a higher pressure of oxygen as well.
Yeah.
For the
yeah, I think
insects.
it was 23% oxygen in the ambers they were finding, which is 3% higher than today. But yeah, that Creation Answers book has a lot of stuff. Like it's well worth reading because it's not a heavy read, like I say. And then there's loads of other more detailed stuff.
Yeah. But I mean, this is the thing, though. I mean, one thing.
You start
raises
picking
another
one thing, and then you start digging and digging and digging.
And my problem is, what do I leave out? Which is there's about 20 other slides there.
Yeah. How do you fossilise that?
Quickly.
How do you do it slowly? Yeah, because it would just rot.
Anyway, that's going to be his talk next week about fossilisation, which again really points to the flood, which is going to be good.
So next week you're doing fossilisation, and you're doing
dating. Just looking at how ridiculous I believe the dating methods are.
Carbon dating.
Well,
We're talking about historical and geological dating,
yes.
Just the age of the
radiometric dating.
Sorry?
Yeah, half-life, the half-life.
Yeah.
How they work it out.
That's it.
Radiometric dating.
Yeah.
And then week 3 I'll look at the genetics and the and evolution, creation. That's a big thing. And without spoiler alerts, we've done the human beings have done the experiments, and we know the data. And the creation model predicts one thing, and long age predicts one thing. Come week 3 to find out. Who was right after all?
But James has brought up a little thing about dating, because you said about an electromagnetic field flip,
Yeah.
which can screw up a lot of things in
Yeah.
terms of dating.
Which is,
Okay.
So that's
And
one
there's
little, tip,
also-
one little tip.
I mean, the dating stuff's a whole
and
another
the
field.
sun could be emitting radiation.
I mean, that's why I
Magnetism.
really want to sort of point you to books.
Yeah, the
and
resources there's so
channels,
much, yeah.
Creation Ministries, and Is Genesis History.
Yeah, good
Um,
start.
Kurt Wise. I've forgotten the other guys' names, but some really, really good.
Andrew Snelling does the geology.
Understanding, yeah.
Creation.com magazine is really accessible. You can read about all the different things, and then if you're interested in biology, go into that, or geology, or whatever avenue, you can follow the rabbit trail there. Yeah. So definitely have a look at some of the resources.
Because I think the principle, the biblical principle is seek and you'll find.
Yeah, and it's true, it
Um,
works. Yeah. Same for this.
So,
But it's also, again, one of the biblical principles is by faith we understand these things. By faith we become Christians, and by faith in creation we take hold of it, and God brings it alive to us,
Yeah.
and we start to understand more of it. Anyway,
Yeah. There's a lot of evidence, but you still have a
we
step of
we
faith.
can't understand it all because it's so complex, and
Yeah.
it is amazing. You know, anyway.
You're right. It's
There'll
unbelievable, but
always
it's
be an element of
But
we
it's-
weren't there, so
Exactly,
we can
yes.
never be 100% sure.
Exactly.
Yeah.
We're not saying we're sure, but that we
it's
believe it's
forensic
good.
science, not experimental science.
Mm.
Yeah.
I mean, that's one of the big things that Answers in Genesis do. It's sort of this is a different sort of science. It is a fair point, but they annoy me. Just being honest.
yeah. Anyone else with a last burning question?
Yeah, I've got one. I mean, do you think the deserts in kind of Africa and the Middle East were created by a huge body of water, like the flood? You've got huge deserts like in the Negev and the Gobi, and
So, creation or secular scientists are in agreement. Historically, there are rivers, lakes,
much
and whatever
wetter,
in
yeah.
somewhere like the Sahara. It was wet. Those who look at there's some interesting. It's another whole world of
Conspiracy
alien
theory.
conspiracy
Yeah,
theories, isn't it? But
Atlantis?
Ancient
you've got
aliens?
things like the water erosion around the Sphinx, etc. Which I don't want to go there either. But you can look at that, and there's a good argument to say that and this goes back a wee bit to your sort of global warming kind of background question. Is the oceans are rising on average. Really difficult to tell because some are going up and some are going down. It's not even. But roughly speaking, on average, it seems to be about a foot 1,000 years or 100 years. I can't remember now. But it's absolutely consistent that it's still happening. There's a good argument to say that this is us still draining down from the flood, because the flood was only 4,500 years ago, the wells are always getting deeper. That's partially human beings, and it's difficult to separate human being caused effects from natural things, but it is clear that the sort of water from places like the Sahara and etc. And so the waters are rising, but there's all sorts
Plus
of
the
things.
whole, we would have been eroded 6 times over.
Yeah.
If the sea was constantly eroding a metre a year around the UK coast, which it is now,
Yeah,
then the UK would have been gone.
Yeah,
If the
why
Earth
is there
was all,
still a UK?
what? Yeah, because after 100,000 years, there'd be much less of the UK left.
and there's good argument
All
that
sorts of things like that.
the English Channel started with a channel and it was broken through in the same way as the Gibraltar Straits were, and you can see that. And the amazing thing about looking at the sort of bathymetry stuff around the oceans is you can see these things now, which 100 years ago you couldn't. But you can look at that and you can see that the Mediterranean would have been flooded at some point. And how did that happen? But as you say,
It would have been dry at one point,
the English Channel is getting wider.
Thankfully.
Well, you don't need to go that far back until when it was when
That's
it must be
another
closed.
argument, David.
Yes, I know.
Sorry, we've gone over.
Right, well thank you so
Thanks for
much.
coming.
Yeah.
I'm going to,
Good, thank
if you don't mind, here you go. I've got
Oh, that's
one
Yeah.
going to a cake on the
Yeah.
other side.
Yeah, that's really good.
Yeah, thank you guys, that's really, really interesting.
So next week, dating, don't expect to go home with a partner.